Okay, thank you. Let's officially get started now. It's good to see you all. And even though I said officially get started, the first thing I do in class is I want to check in with you all. How are you doing? Any questions or comments up to now? Anything? Okay. Again, it's really good to virtually see you at least. And I appreciate that you're meeting me that you agreed to meet me online this morning, and definitely Tuesday we'll be back in class. But the other thing I like to do at the beginning of class, if this is okay with everybody, is just take 60 seconds for a little bit of silent prayer. I don't want to try to lead prayer for anybody else, definitely. And so if we did take this 60 seconds together. And I put a little timer on because one time we had 60 seconds and it turned into like 5 minutes. So you're going to hear a little bell at the end of this. So if that's okay, we'll just take our minute right now. Okay, that was it. Thank you so much for taking that time and allowing me to take that time. I appreciate it. Okay, so let's get started. I want to just kind of run through what this class is about, go through the syllabus, things like that. We will do a little bit of math today, but we will get done early as well. Okay, so this is Calculus 1. Everybody should be in the correct spot, I hope. Okay, and this class, calculus basically studies two things at once. It studies how things change, how quickly things change, and it also studies what happens when you try to combine things together, the study of aggregation, put things together. And there's an actual relationship between the two things, which is called the fundamental theorem of calculus. In the announcements, I think you saw that I think that the ideas in calculus are some of the most elegant in the entire Western thought, the canon of Western thought, and that's definitely true. And the reason is because the relationship between the two exists. I mean, why would somebody think that how things change is related to adding things together? I don't know, but definitely that's it. But I'll stop with that. Hopefully this will come through during class. Okay, if you haven't had pre-calculus, okay, then this is going to be a tough class for you. It's typically a pretty tough class for people, but we can get through it. It's definitely a doable class, but it's going to require some work and probably pretty regular study. You can't really cram at the end of the week and do all your homework on the same day in this class. You really have to do a little bit of calculus every day in order to get good at it. And for those of you who are engineers, I think everybody in our class is an engineering major. For those of you, this is the basis of all of the stuff you're going to do in your other classes. So this is actually a really important class for your major. Okay. Let's look at Halo, first of all. And the very first thing in Halo, let me make this smaller so everybody can see it in class, is to make sure that you answer this discussion question. Looks like only one person has answered it so far. Open up discussion question. Oh, the class introductions. So this is a GCU thing. If any of you are new to GCU, they always ask you to answer these questions. You do not have to go, Jax did a great idea. Oh, big data, awesome. Yeah. Jax did a really good job. It's always good when you can tell me about things. about yourself. That helps me quite a bit, but you do not have to go into a lot of detail. You can just go online and go, hi, I'm so-and-so. I'm in the class and I'm ready to get started. You don't have to put a whole lot of detail in. Okay, but please answer this. This is a GCU thing, and they will tell me if you haven't answered it. I mean, I'll be able to see it, but I will get an email, and I'll have to chase you down and tell you to answer the question if you don't. That's just a strange thing about GCU that they ask about everybody. So please answer that. This is part of your participation for this week. So please go ahead and do that. The other discussion questions that are in class, we will not do those online. We'll do those in class, so you don't have to worry about answering them on Halo at all. So there's the getting acquainted discussion question. Also, I keep a Google Drive with handouts, and when you look in the announcements, you'll see the link to that. Right down here. And you'll see I've already got a couple of things in this Google Drive. I've got a little syllabus. Let me move this up a little bit. A syllabus, and I've got a handout for you called the Library of Functions, which we'll look at later on today. And then at the top, there's this folder that says Class Notes, which right now is empty. But as soon as we're done with class, then these notes that we go through in class after they've all been filled in with ink and everything, those will go up in the Google Drive for you. So if you ever do have to miss class, you can see what we missed. Or if you want to go back and study for exams and things like that. So those are the first two things in there. The next thing in Halo is that we're going to use a computer system called Derivita. Let me move this little guy up out of the way. For our homework. And if we go to the class resources, oh, actually it's not in the resources, it's in the calendar. Every class they put things in different spots. Come on, Halo, do your job. If you look at the homework, this is not how it looks for you. This is how it will look for you. Okay, you've got your homework here. So you can answer all the questions in the homework through here. Okay, now if you get your question wrong, say I say it's 42. Of course, I pick a question that's got a whole lot of things. Let me pick one that's a little shorter. Let's say the answer here is 42, and the answer here is the interval from negative infinity, which is nice, up to infinity. You can actually type those things in as well. Okay. First of all, the first thing to notice is that it gives you this little palette of symbols to enter things in. Second of all, over here, it'll show you what your answer looks like, so you can see if it's formatted incorrectly and make sure that it's what you want to have. And then when you check your answer, I'm going to submit. Bummer, I got the answer wrong. Okay. You can try each question 3 times. And if you get the answer wrong after the 3rd try, that gives you a little explanation. Okay. But you can redo the question. It'll give you different numbers, but you can redo the question. So here, my domain would be 8 over 4 is 2 to infinity, I think. And the range is 0 to infinity. Oh, it must be -2 then. I can't think in my head. I have to write things out to get it right. Okay, well anyway, Anyway, if I don't write it out, I can't get it. But once you get it, okay, then you'll get credit for the question. So even though you got it wrong, you can still get 100% on your homework by redoing the questions. So the homework is where we want you to practice. If you've ever done any sports or any music, or if you've been in plays or anything like that, if you're a thespian, you know that you rehearse and you rehearse and you rehearse, and it doesn't matter if you make mistakes because that's where you learn. And then after, whoops, got somebody coming in, yay. And then after the rehearsal is the performance, and that's where getting everything right is important. So we want you to practice to get all those mistakes out so you do well on the exam. I'm sorry, question? Hello? Okay. All right, let's move on. So we're going to have derivative for our homeworks and exams. Okay, exams will also be in derivatives, and we'll have practice exams. And then we're going to have MATLAB that we're going to work on for 3 projects in class. So in addition to our regular weekly homework, we're going to have these 3 special assignments. Let me open up MATLAB. This is a professional level software package. So this is something that you'll actually use in your jobs. Okay, everything's working slowly this morning, and I think that's just because I have so many things open at once between Zoom and recording the screen. So here's MATLAB. It's got some getting started. When we go through the projects, we'll talk about them in class, and I'll help guide you through working in MATLAB. But basically, you can program in here. It's a script. I don't remember the name, but it computes in real time. You don't have to compile. It will work everything all at once. So what have I done here? I just added 2 numbers and it gave me that. And then here I assigned a variable. I said x is equal to 4. And then I asked it to tell me what x plus 2 is, and it answered. It said x plus 2 is 4 plus 2. If you haven't had any of your programming yet, or if you haven't had any experience with programming, don't worry. If you have, this is going to be really easy for you. No worries at all. But if not, don't worry. We're stepping you into it. You'll use MATLAB in your other classes as well. And so we're just starting. The purpose of this class is to get you started working with MATLAB. So that's that. So how are things? Okay so far? Any questions? Oh, we've got 3 projects that you'll have to do, 3 assignments. And I think the first one is in week 3. Let me double check. Yeah, the first one is actually an intro to MATLAB. So this one is going to step you through sort of how to get used to working in MATLAB. Okay. And then it'll have some exercises that it wants you to do at the end. And so what you'll do is you'll write a script to do these exercises, and you'll actually hand in the MATLAB file. And so when I get it, I'll just open up MATLAB and run it and see what you have in your MATLAB file. I'll make sure that your file runs and that you've put in the correct commands and that you've done the calculations. And then the second one is analyzing, I think, a kinematic equation, something being tossed through the air. And I don't remember what the third one is, but 3 assignments like this. They're not huge, but they're worth 40 points each, so they're a little bit important for your grade. Does that help? You're welcome. Okay, let's see, what else have I got on this handout? Let's see, derivative, MATLAB, and oh yes, in the announcements you saw I had that little survey where I asked you your name. I'm asking you your name and your major, and if you've got something that you'd rather be called instead of the name that GCU calls you, please let me know on that, because I want to call you the name that you want to be called. So this is a good way to reinvent yourself. However, whatever you pick is what you're going to be stuck with. I did have a guy decide that he wanted to be called Fruitcake for the whole semester, so the whole class called him Fruitcake. I think all the way until he graduated, people were calling him Fruitcake because of that. So just be careful if you choose a new name for yourself. All right, let's see what else. Let's come back to the Google Drive, and I want to open up this handout for you all. We'll just look at grading and make sure everything's taken care of. So textbook, you need Derivata, MATLAB. Of course, you're going to need a laptop because all our homework is in Halo. So you're going to need that. For exams, you'll definitely need to have your laptop in class for exams. Make sure that it's charged up so that you don't lose battery in the middle of your exam. That would be a really bad thing. And in this class, you can use a graphing calculator on exams. So if you have a graphing calculator and you've been upset in your previous math classes about not being able to use it, you can use it. But you don't need it, so don't run out and buy an expensive calculator. I don't think it's really much of a help for the exams, but if you want it and you've got it, go ahead and use it. So let's see. Every week we've got homework in Derivata. Okay. We've got 3 exams in class. These are the dates for the exams right here. So please make sure that you are in class for exams. And each exam will have a practice exam. So you can kind of see what kinds of questions will be on the exam to be able to practice for those. And then the 3 MATLAB projects that are in class, or not in class, but that'll be due during the semester. And then participation. So it's a pretty straightforward class as far as how things are assigned and the grading and everything. Then here's all the official stuff: participation, late policy, academic honesty. Okay, all of that stuff's there. If you are a student who needs accommodations for anything, you know who you are already. Please, please, please make sure your paperwork is done. I'm not allowed to give you any accommodations until I hear from the SDS, the Student Disability Services Office, from them officially. So get your paperwork in as quickly as you can, because I can't help you unless you get that done. Okay? And then finally, at the end of this handout is just a kind of a handy calendar. Some people like to have this. I like to cut it out, and well, when we had textbooks, I kept it on the front page of in the front cover of my textbook, but now I just kind of carry it around with me. So if you want a real quick calendar of the whole semester, there it is right there for anybody who wants it. All right. Anything else there? Nope, nothing there. All right. So any questions you can think about how the class is going to run? Anything? Anybody? Okay, let's get a really quick start on the first topics material. We won't take the whole day, but I want to do a little bit. So let me open this up bigger again. And we're going to spend today and all of next week doing a really, really fast pre-calculus review. I taught pre-calculus Math 261 last semester, and so I know what we covered in our class, and I know what was covered on the homework and the exams. And when I looked through this homework, there were some things that they had that really weren't covered very well, I think, in the pre-calculus material. In Alex, if you had Alex at all, it didn't have any questions about this. So I'm going to give you a quick review on those important things, and the things that I think that Alex really didn't cover, we're going to look at those in a little bit more detail. But today, just really quickly, we're just going to talk about functions. Okay, so you know, a function, it's a rule or a relationship. It's got inputs, it's got outputs. Every input has exactly one output, not more than one output. Okay, that's what makes it a function. And what we're going to stress in this class is called the rule of 4, which are 4 different ways to look at a function. So if you think about that old story about the blind men that looked at the elephant, well, they didn't look at it because they were blind, but they came up and encountered an elephant, and like one put his hands against the side of the elephant and said, oh, I know what an elephant is. An elephant's like a wall. And another guy had the elephant's trunk, and he said, oh, I know what an elephant is. It's like a snake, you know, and all those different things. So that's kind of how functions are. We want to look at them from different aspects so that we can get a better view of exactly what a function is. And so the rule of 4 is 4 ways to look at a function. We can look at it analytically. So that's with the formulas and the equations. That's something like f of x equals 3x squared plus 2. Okay. We can also look at a function graphically. So if I were to graph 3x squared plus 2, it would look kind of like that. Okay. We can look at it with data. So I can have a table of x and y values, etc. And we can do it with words. So we can say square the number, multiply it by 3 and add 2, or we can also use words to describe what the real situation is. Now this is a math class. Not all of our functions are going to have real life situations, but you're mostly, if not all of you, are engineers, so you're going to be working with real life situations for most of your program. So the idea is that we want to be able to see all of these together. We want to combine them together so that if we have one of these ways of looking at a function, that we can see, at least in our mind's eye, the other ways. So we want to integrate these together. Those of you who had functions, this is not integrate in the calculus way. This is integrate just like combining. We want to be able to see how these all fit together, how they relate to each other. So that's going to be a focus in this class. Okay? And that's one of our goals for the class. Once you start to understand, like when you see an equation, how that looks graphically, or if you see data, if you can find a way to make the equation for that, that is where you start to really get the power behind mathematics. So I hope during our functions that we start to focus on those things during the semester. Okay? Let's look at a quick example. Suppose you had a really good Christmas, and for some reason you were on top of a 400-foot cliff and you decided to shoot a pineapple in the air. Okay, so there's describing the function. What is the height at any given time? So there's talking about the function in the words. It's the height of the pineapple after any given time after you shot it. Okay? So there's one way, words. Okay? Another thing you could do is you could actually go out and measure it. Okay? You're engineers, you measure stuff. So you could say, as time elapses, the height. So maybe when the time equals 0, the height would be 400, right? And then maybe after 3 seconds, the height is 262. And after 5 seconds, the height is 10 feet above the ground, and so forth. So there's your data. And then you could graph that data. So 0, 400. At 3, I'd have 262. And at 5, I'd have 10. Not to scale, definitely. And so we've got kind of a graph there. But what we'd really like to have would be the equation for this. So sometimes we could take the data or the graph and we can use that to find the equation. In this case, because this is a situation we know about, we can use Newton's kinematic law, kinematic equations, and we can get this equation. And these are 4 ways to talk about the same situation. Okay? If we were to graph that equation, we'd get that graph. Okay? If we were to put points into the function and get our outputs, we'd get the table. Okay? Each one of these things gives us different information. The graph and the equation are going to be the 2 most important ones for us in this situation. From the graph, we can see really well what's going on. This thing definitely goes down. Okay? From the equation, we can get more precise information. We can find out exactly when it's going to hit the ground. We can find out how high it is at any given time from looking from that equation really easily. Let me put analytically here. Okay, so the equation is going to be really helpful for us, but connecting that to the graph is going to be really important for us as well. Okay, here's another example. This is an example called a piecewise function. So piecewise functions are written like this. Trying to read my handwriting on my notes. I think these are what I've got written. Oh, and I need to change that. That should be a less than, not a less than or equal to. Okay, so there's a function written out piecewise. We can evaluate this function. Maybe if I asked you for f of 30, the way you would figure out how to calculate this. Let me move this out of the way. Oh, I see some chats. I'm sorry. Oh, just some yeses and nos. Okay. All right. Is I would look here and find out that 30 lies between 10 and 100. And so this tells me that I would use the 3,400 minus 30, which is 3,100, okay, to find out how that function works. Or if I wanted to know f of 5, the first thing I would do is find out where 5 is. 5 is in the first interval, so that tells me to use the first function. Is this new for anybody? Let me know. Just making sure everybody's worked with piecewise functions. Okay. All right, so there's our analysis right there. We can also graph this. Between 0 and 10, we would graph 4,000 minus 50t. So that's at 3,500. And then between 10 and 100, we would graph 3,400 minus t. Definitely, again, not to scale. And then when t is bigger than 100, my graph, so this is 3,400 minus t, and this is 3,300 right here. So we can graph our piecewise functions as well. And let me put some colors in. So this corresponds to the blue that's up here. This corresponds to the yellow that's in the middle. And this corresponds to that part right there. So we can see how that function works like that. Okay? And we didn't talk, I know in my class we didn't talk much about piecewise functions, but these might be more important for us. Definitely in differential equations you'll start to see more piecewise functions. Those of you who are in electrical engineering, you'll see a lot of them because digital circuits work like this. When you turn a switch on, all of a sudden something else happens, so the function changes. But this could be a rocket, and the mass of the rocket as it's flying through space. So in the beginning, it's losing fuel, so its mass goes down as it burns the fuel, but then maybe it drops a payload. Let's not say loses fuel, let's say burns fuel. And then it drops a payload. So that accounts for that little drop right there. And then after it burns all its fuel, then it just floats out and becomes space junk. So each of these three things describes a different thing that's happening in this thing that's going on. Okay? So there are a couple of examples of functions and different ways we can look at functions. Okay, let's real quickly talk about a library of functions. There are some basic functions that you just need to know what they look like. And this is a handout in the Google Drive. Those of you who had me last semester, I gave you an abbreviated library of functions. This handout has got more functions on it. And this is not mine. I actually took this from someplace, from another school. The one I gave you last semester was one that I made. So it's got definitely a lot of functions, but yeah, x squared, x cubed, square root. Notice on all of these, they're giving you some important points on the function. And also, they're giving you, I don't know if I can write on here, they're giving you the domain and the range. Here it is. On each one of these, they give you the domain and the range. Okay, so it's going to be important to know that domain and range, especially for this, well, especially for everything, but during the first homework, we're going to have transform functions, and we're going to need to look at domain and range. So knowing the basic ones is going to be important for us. Let me clear that and close that out. So that handout is there for y'all. Whoa. Okay. And then I want to talk a little bit more about domain and range as well. And then we'll be done for today. You've got some questions in the homework about domain and range. So just as a quick reminder, if you have a rational function, to find the domain, it's going to be all real numbers except where the denominator is equal to 0. So for example, if you had the function f of x equals x minus 2 over x squared plus 3x plus, let's see, things that add to 3. 3 and 1, 2 and 1, plus 2. And you wanted the domain. You'd take x squared plus 3x plus 2. You'd set it equal to 0. You'd solve it either by factoring or using the quadratic formula. And so you'd say x equals minus 2, x equals minus 1. And so your domain would be from negative infinity up to negative 2, not including negative 2, so are the round parentheses. And then you would continue from negative 2 to negative 1, not including the negative 2 or the negative 1. And then you would go from negative 1 to infinity. Now I'm going through this fast because I know you've had this stuff before, but it also may have been a while for some of you. Any questions on how I'm getting any of this? The interval notation okay? The unions? Stuff like that? Feel free to ask, or feel free to let me know in Halo also. If you've got any questions, I know I'm skipping a lot of steps. So if there is a detail here that you're going, what the heck is she doing? Or maybe you didn't see it in another class or it's been a long time, be sure to let me know. Okay, then. So for rational functions, that's how you'd handle those. For even roots, so like a square root, a fourth root, a sixth root, so and so forth, you want the argument, the thing inside the root, to be bigger than or equal to 0. So for an example, if we had y equals square root of 49 minus x squared, and I'm doing simple-minded examples. They're a little bit more complicated in the homework, but I want to do simple ones so that you can see the process. So you would take, for the domain, you would take 49 minus x squared greater than or equal to 0. And then, because this one is non-linear, you would set it equal to 0 and solve. And again, I'm going through this part really quickly, so if there's any detail you want me to show you in more detail, let me know. Then you would plot those on a number line, and you would test. Over here, you'd take a number at random, so maybe negative 10, you'd put it in. And that's definitely less than 0. But we want greater than or equal to, so no solution there. And then in the middle, you take a number. I'll pick 0 because it's an easy one. That's greater than or equal to 0. But we're comparing it to greater than or equal to 0, so that tells us, yes, there is solution there. And we would continue. And so the domain here, of course I ran out of room. Would be from negative 7 up to 7 in that case, so for nonlinear. Okay, and let me just remind you, for exponentials, the domain is all real numbers, so from negative infinity up to infinity. For logs, no matter what the base is, your domain is going to be argument greater than 0, not greater than or equal to 0. So for example, if you have log base, I don't know, 5 of x minus 7. The domain would be x minus 7 greater than 0, x greater than 7. There's your domain for that one. Let's see, exponentials, logs, even roots we've got. And then for sine and cosine, the domain is all real numbers. And for tangent, the domain is all real numbers except the argument equals pi over 2 plus multiples of pi. Whoops, not 2 pi. This isn't going to show up on the homework, but it will show up next week when we talk about the inverse tangent function. So remember, the graph for tangent looks like this. This is pi over 2. This is negative pi over 2. And then it repeats every pi. So that's what's going on that. Okay. This is all I have for y'all today. This should get you started on most of the first, 10 or so questions. There are 30 homework questions for the week. So this should get you started on the first, maybe 10 of those as we go through the homework. Any questions you can think of right now? Anything? Oh, got a chat question. Let me check it. Oh, no questions. Okay, good. Okay, then, because it's the first day and because we're on Zoom, I'm going to let you all go a little bit early today. In the future, we'll start right at 7. Okay, I'll come in before 7, but I don't like to start before 7. So we usually start right on the dot and plan on staying the whole time. Okay, and let me see if there's anything else that I should let you know. No, just for next week. Answer the welcome to class DQ, because GCU will really be upset if you don't. Okay. Answer the survey that I put. I think I called it the first day quiz. In the announcements. This is what your participation is going to be based on this first week. Okay, read chapter 1. And start on the derivative homework. The textbook is in the class resources. Yeah. Start derivative homework 1. And that's it. Yeah, there's one more comment about the textbook. This is a really good textbook. This is such a good textbook. It's been around for decades because people really like it. It's been updated, of course, as time goes by. But I didn't take out of this book, but it's a really excellent textbook. If you like printed books, you can probably find a used version of this book pretty cheap because it's been around forever. Even early editions are good versions of this textbook. So if you do like printed books, I'd say go out and try to find a used one really cheap. You don't need to get the current edition. That's all about that. Any other questions, comments up to now? It should be. It shouldn't be too much older. Okay, between you and me and the fence post, the textbook publishers, they'll change the questions and they'll change a little bit in the textbook so that they can charge you guys for the new edition. So a lot of it's political. If you get one that's really old, if you get one, I'm talking about, if you get one that's 20 years old or older, it will probably have a different approach. Like the rule of 4 came around in the mid 1990s. Yeah, I would say the mid 1900s. The mid 1990s is when the rule of 4 came around. And if you get anything older than like 2000 and older than 20 years or so, it's not going to have as much technology. It's not computer applications. So I wouldn't say get a 20-year-old book, but if you can find one within the last 10 years, you're good. Anything else, anybody? All right, excellent. You guys have a wonderful weekend. Thanks again for meeting me on Zoom, and I'll really look forward to seeing you in person on Tuesday. Take care. Have a good weekend. Thank you too. Bye-bye.